I said a while back that I was going to start doing some videos delving into a topic that I wrote a book about that I published back in 2009 called The Ultimate Observer. And basically it was talking about how the idea that our universe, our reality, is what we would call a virtual reality simulation, how that can tie into the idea of a creator, specifically a biblical type of creator who has the power to intervene in our day-to-day affairs and so forth and do miracles, how it would relate to the idea of prophecy in the Bible and so forth. And it's taken me a while to get back to that. Lots of things going on. But I wanted to do a video about what would be the basic foundation, the most fundamental rule in a universe like that, like a simulated universe. If we were going to create a universe like ours and set it up for some people like us to experience it, what would be the primary rule? And the term that I coined for that and that I used in my book was the conservation of computational energy, just because it sounds like a law, It's not like traditional conservation of energy in physics, where you're talking about energy can't be created or destroyed. But the idea that you're not going to use any more computing power than is absolutely necessary to do the job. And the basic idea as it would relate to a simulated universe is that nothing in that universe would be displayed at any higher resolution than is absolutely necessary to maintain the illusion of continuity and solidity within that frame of reference. So that's the idea. And that overarching idea has a big effect on things. And when we look at our universe that we live in, we can see the effects of that same philosophy at work. The interesting point about it is that if you're not going to display things at more than a certain resolution, it means that you don't also have to keep track of things. Sorry, I'm kicking my table here. When you think of this universe as a virtual reality, the thing you have to remember is that when we talk about it as a virtual reality or a simulation, our universe is a display. It's like a three-dimensional display. It's, the computing is taking place somewhere else. Our universe is not a computer. It's not a machine. You go back to some of the early ideas about things like a more mechanistic point of view, where even in relation to the idea of God, people talk about a God who just kind of wound things up and started the machine and let it go. And which is another place where you get into the idea of, well, then how can he intervene in things if it's just a machine that he wound up and started and let go? Where is there room for him to act after that? With a simulation or a display, it's a situation where all that computing is taking place somewhere else, in either in a computer, or, as I pointed out in my book, you could substitute for computer the mind of God. We have no idea how to understand that, what that would be like. That's a topic for a different time. But let's just look at it from like a computing point of view. And or you can imagine a being who is so advanced and has a mind that is powerful enough to run a simulation like this in their mind and keep track of everything. Like I say, trapped within this reality, we have no way of knowing. That's one of the reasons why you'll find that science, in terms of the scientific method, they refuse to consider the possibility of anything outside of this universe. First of all, because there's no way they could say anything about it. So they try to find theories that can just use what we see within our universe as the only explanation and assume that it's an accident. It works all from the ground up, and that's where they run into trouble trying to explain things, especially when we get into things like quantum uncertainty and so forth. Because the question arises, if you have all this uncertainty about certain things and the fundamental particles, or once you get down to a certain level, once you scale things up, how is it that then you find a universe that is, for the most part, predictable, and you don't have to worry about things just suddenly, changing, or we just have a probability of seeing things in a certain place. We know, what's going on, and we can predict things, and it seems solid and continuous at our level. But if you look at things as a simulation where things were designed to appear solid and continuous at the level of detail that our human senses are capable of resolving, then it's different. You can look at things from a different point of view. It may be that our universe is based on a real universe where those kinds of particles, let's say our universe is an exact replica of a real universe. And in that real universe, those subatomic, subnuclear particles actually all are there and exist. And there's no kind of uncertainty about what they're doing, because they're really there. For us, it's different, because in our universe, the only thing that matters is that it looks solid on the level that we interact with it. Once you get down to a certain level, there's no point in keeping track of all that stuff. These, you're not going to keep track. Say, let's take the sun, for example. We have this massive nuclear furnace out there that is capable of sustaining itself and putting out a pretty consistent level of energy for tens of millions of years. If you have a simulation and you're displaying that in a simulation, do you really need to keep track of every single little tiny, countless tiny subnuclear particles and every little atom and what it's doing? You don't. All you need to know is, okay, it's that big giant ball of fire, and everything that's happening below a certain level. I mean, you know what it's doing. The laws are there that govern its operation, but you don't have to actually keep track of every single little particle. If we were running a simulation, that's how we would do it. And if you look at things, if you look at this universe, and the idea that it was created, that's what you have to do. You have to put yourself in the shoes of the person who's running the simulation. How would we do things? What makes sense? And what would be logical to us as the people who are creating that and setting up that world? Now, if you're not going to keep track of all those things, or display all of them below a certain level, there's no point in keeping track of all that. If we want to know the exact position and momentum of an electron or whatever, we can't do that. The more certain we are about one thing, the less certain we can be about the other properties. And we have there's a certain probability of us finding it in a certain place or whatever, but there's no absolute certain way of doing some of these things. And the reason is because even though the principles are there that govern its operation and what it's doing and how it works and how that scales up, how that explains chemical interactions and so forth, there's no need to keep track of it. So if we perform an experiment that allows us to dig down to that level of detail, a result has to be provided to us. And it's much easier if the universe is a simulation and you're not really keeping track of all that, just to provide us with an answer that's within a certain realm of probability. And you just, whenever that result is required to be displayed, you roll a dice and it comes up within certain parameters and there's a result. And that eliminates the need to keep track of all those things that are going on, that there is no point in keeping track of. It's just not relevant. If the universe was real, as terms of what we consider, real, physically real, there wouldn't be any uncertainty about a lot of these things. It's like, Like if you look at a distant star, if you're trying to keep track of like a photon, some of the experiments, like which side of this star or that star, did that light beam travel around on its way to us from a distant galaxy, 10 million light years away. This experiments have been conducted that even on that scale, the result of that experiment, it isn't really determined until we look and we try to find it. If there had really been an actual real photon traveling through space for 10 million years to get to us, when we look and we see it, there would not be any uncertainty about what path it had taken. The reason we see an uncertainty is because it wasn't really there until we looked, and a result had to be provided for us. And so a result was provided to us within the realm of certain parameters and probabilities. That's it. All these things are evidence that it's just not what we would call real. Now, physicists and cosmologists have tried to come up with all kinds of, interesting theories to explain this all away. Like at the moment of us observing or interacting with that particle, particle that travels back through time, goes back to the source and does something. Anything to try and evade the obvious conclusion, which is that it's a simulation. And, there's a rabbi, Tovia Singer, who has made the point, I'm probably not phrasing it exactly right, but he's talking about, why God rested on the seventh day. And he made the point that if God had continued on and really finished the universe perfectly, it would have been so perfect that we would have no way, he would be totally hidden from us. And, really, we can kind of look at it, all this evidence we see of, the conservation of computational energy is kind of the way God signed the universe. Now, we'll have to have another discussion about who exactly is running the simulation, because that's a key point. If there is a simulation, if that's what this universe is, then someone is running it, and there's a reason for it. And that's a totally different point. But in this video, I just wanted to talk about that main basic concept, the conservation of computational energy, because that explains so many things that people think are kind of, counterintuitive about quantum mechanics, quantum physics, and so forth. Why, if we see this uncertainty at this basic level, when you scale things up, does the universe seem to be deterministic? And it's because in our universe, all those things, it doesn't really work from the bottom up. I mean, from a theoretical point of view, it works from the bottom up. But in this display of the universe, it's just being displayed at the level that it needs to be displayed. We can get into later as well, there's kind of like a refresh rate, if you will, or a frame rate for how things are displayed. And in between each frame, things can be adjusted. You can intervene in things. There are certain physical properties that things have that we have to know about, say like, mass, energy, angular momentum, things like that. Those are the qualities that everything has. And from one, from one frame to the next, as things are adjusted and move through time, those qualities, as long as we know those qualities, those properties of things, and we have a certain set of rules by which we can, like the theories and rules of the universe that we can use to make the calculations to determine where all that stuff goes to the next frame. That's all we really need. Excuse me. Some sinus stuff going on. But that's the key. As long as we keep that in mind, that one basic principle, it really helps us to understand why things are the way they are in our universe. And that's the biggest clue that we have, that we are in fact living in a simulation. And how we can extrapolate some of that stuff, in terms of, religious or biblical things and other kinds of scientific issues. We'll get into that later. Thank you.